Welcome back to Syntax Grid. In today's video, we're diving into Naïve Bayes, a powerful machine learning algorithm based on probability theory. We'll cover what it is, how it works mathematically, why we use it, real-world applications, and its pros and cons. So stick around till the end. What is Naïve Bayes? Naïve Bayes is a classification algorithm based on probability and statistics. It is widely used for tasks like spam detection, sentiment analysis, and recommendation systems. But why is it called naive? Because it assumes that all features in the dataset are independent, which is rarely true in real-world data. Despite this naive assumption, Naïve Bayes still performs exceptionally well for many classification problems. Imagine you're deciding whether to bring an umbrella. You check if it's cloudy, if the forecast says rain, or if your friend tells you it's raining outside. Each factor influences your decision independently, but in reality they are related. Naïve Bayes treats them separately but still predicts well. Example: let's say you're deciding whether to go for a morning run. You check if the weather is good, if you have free time, if you feel energetic. Each factor influences your decision, but they are not truly independent, yet Naïve Bayes treats them as if they are to make a prediction. In real-world applications, this approach is fast and effective for classification tasks, even when features are dependent to some extent. Mathematical explanation, Bayes' theorem, and probability. The Naïve Bayes algorithm is built on Bayes' theorem, which calculates conditional probability. In simple terms, Bayes' theorem helps us find the probability of an event happening, given that another event has already occurred. Mathematically, it is represented as PAB, probability of A happening given that B has happened, PBA, probability of B happening given A, PA, probability of A happening independently, PBB, probability of B happening independently. For example, if we are classifying emails as spam or not spam, Naïve Bayes calculates the probability of an email belonging to each class based on words present in the email. The class with the highest probability is selected. Fun fact: did you know Google's Gmail filters over 100 million spam emails per day using algorithms like Naïve Bayes? Why do we use Naïve Bayes? Now, you might be wondering, why use Naïve Bayes? What makes it special? Fast and efficient. Naïve Bayes is one of the fastest classification algorithms, making it ideal for real-time applications. Works well with small data. Even with limited training data, it can make accurate predictions. Perfect for text-based data. It's widely used in NLP, natural language processing tasks like spam filtering, news classification, and chatbots. Performs well on high-dimensional data. If you have a data set with many features, like text data, Naïve Bayes can handle it efficiently. Easy to implement. Compared to other complex models, Naïve Bayes requires less computation power and is easy to code. Real-life example. E-commerce companies like Amazon and Flipkart use Naïve Bayes to classify customer reviews as positive, neutral, or negative in real time. Of course, it isn't perfect. We'll discuss its limitations later. Real-world applications. Naïve Bayes is widely used across industries. Here are some real-world applications. Spam filtering. Email services like Gmail use Naïve Bayes to classify emails as spam or not spam based on keywords and sender reputation. Sentiment analysis. Companies analyze social media posts and customer reviews to determine if feedback is positive, negative, or neutral. Medical diagnosis. Used in healthcare to predict diseases based on symptoms. For example, predicting whether a patient has the flu or not. Text classification. Used for categorizing articles, blogs, and news into topics like sports, politics, or entertainment. It's truly an incredible algorithm with practical uses in everyday life. Cool fact: did you know Netflix's recommendation system is 80% responsible for user engagement? Limitations. Naïve Bayes oversimplifies real-world data. It assumes features are completely independent, which isn't true in most cases. Struggles with highly correlated features. If two variables are strongly related, Naïve Bayes may not predict accurately. Zero probability problem. If a word never appears in the training data for a category, the probability becomes zero, leading to misclassification. And that's a wrap. We explored what Naïve Bayes is, the math behind it, why we use it, real-world applications, its pros and cons. Naïve Bayes is a powerful, simple, and fast algorithm that works well for classification tasks, especially text-based applications. If you found this video helpful, don't forget to like, share, and subscribe to Syntax Grid. Got questions or suggestions for the next video? Drop them in the comments below. Thanks for watching, and see you in the next one.